All right, guys, so we are back for our second video for week 4. So this is going to be dealing with 4.6 to 4.10. So that is your slope-intercept form, point-slope form, line of best fit, which we're actually going to graze right on over. We're going to be dealing with our slopes of parallel and perpendicular lines and transforming linear functions, okay? So we're going to start off with your slope-intercept form. Remember from your Prezi presentations, your slope-intercept form has to be written as y equals mx plus b. So that means you're going to be needing to rearrange a formula or rearrange an equation to look like this. So let's take, for example, 2x plus y equals 5. I need to get this y all by itself. Think of it as solving your equations where you were trying to get your variable all by itself. In this case, it's going to be the y value. Means I need to get rid of that 2x. So I'm going to move the 2x by using inverse operations. So I'm going to subtract it from both sides. Now, remember, these are not like terms, so they cannot be combined or subtracted from any of those things. So I'm just going to go ahead and write them right next to each other. So remembering that my order needs to be mx plus b makes it easier for me to graph and identify items. I'm going to put that negative 2x first. And then I'm going to put the positive 5 right after it. And there we go. I've now made it into slope-intercept form. So let's say I wanted to graph that line. So I'm going to, you know what? Let me do this. All right. So I'm going to take this. Let me grab this one. Okay. So I have my coordinate plane here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 4, 5. All right. So I need to look at my equation first. Let me see if I can get them both. All right, perfect. So this is my equation, right? I know I can graph this, right? I first need to look at my y-intercept value. That's always going to be the first point that goes on your graph. So notice that it's a 5. In our last video, we talked about our y-intercepts being that when x equals 0, y equals whatever that number is. So that means that my x value is 0, so I'm going to be here, and I'm going to go up to where y is equal to 5. So that's my first point, okay? I'm going to kind of zoom it in just a little bit for you guys. Bring this down. All right. So notice here, my slope is a negative 2x, okay? So remember that we were dealing with slope, it's rise over run. But if I have a whole number, it's always going to have a run of 1. Because think of it, if I were to put that in a fraction, it would be negative 2 over 1. So that means that I'm going to go down 2 points from my y-intercept value, and I'm going to run 1. So I have this point right here. Now, just to make sure that my line's going in the right direction that it needs to, I'm going to do that slope again from this point. So I'm going to go down 2 over 1, and just one more for good measure. So down 2 over 1. Now, I can connect a smoother line, and I've now graphed my linear equation, okay? So it's really not that difficult for you guys to be able to graph these equations. It's just remembering that your y-intercept comes first, and then from there, you do your rise over run for your slope, okay? So now, we're gonna go ahead and move on to, where did that silly marker go? I'm telling you, that marker's always rolling away from me. All right. All right, so let me go ahead and put this away here. So we're gonna graph a line. Actually, no, we'll skip those, it's fine. Actually, you know what? Let's go ahead and do those. So we're gonna graph a line that has a slope of -3. No, let's choose something a little bit more difficult. So let's do a slope of -2/3. So slope negative 2/3, and it passes through a point negative 3, 5. Okay? So what I'm gonna do is I'm gonna go ahead and plot this point first, and then I'm gonna go ahead and do the slope from there. Okay? So I have a negative 3, 5, so that's gonna be around here. Now, my slope is negative 2/3, which means I'm going to fall 2, so I'm gonna rise a negative 2, which means I'm gonna go down 2, and then I'm gonna run 1, 2, and 3. So that's actually gonna give me the point right there in the middle, which that is called our, y-intercept value. Now I'm just going to go ahead and connect those 2 dots there. It's an awful line, but it'll do. That would be the line that contains that slope and passes through this coordinate point. So it contains the coordinate point that it passes through, and my slope got me another point on that line. Now, notice from our slope here, it's a negative 2/3. So my line should be going down from left to right, and it is, okay? That's another way that you can always double check yourself to make sure that you've graphed it correctly. It should be going in the direction that you need it to. So again, if this had been a positive and my line was going down from left to right, I know I did something wrong somewhere, okay? You need to really pay attention to those. So the next part that we deal with is your point slope form, okay? So I'm gonna write the equation at the top for your point slope form. Okay, so I have y minus y1 equals m times x minus x1, where these 2 points here are a coordinate point that they've given you, and your m is the slope that you found. So let's say that I want to find the equation of a line that goes through 3, 1 and 4, 3. So before I can even input a value into here, I need to find what the slope is. So again, I'm going to label these as my y1, x1 and y1, x2, y2. So I have 3 minus 1 divided by 4 minus 3. It's going to give me 2/1. So that means that I have a slope of 2. So I can take this 2 value and plug it right up into here. So I'm going to get rid of this for now so that I can have space. So I'm going to put over here that m is equal to 2. So I'm going to take the same coordinate point that I kind of said was x1 and y1 and take those to plug into here. So again, I have y minus my y1 was 1 equals my slope of 2 times x minus my x1, which was 3. Okay? So I have it here. I need to simplify it down to where it's y equals mx plus b. So I'm going to go ahead and distribute this first. You always want to simplify each side first before you start your inverse operations. So I get, this side is still the same. I get 2x minus 6, okay? Now that I've simplified this side as much as it can, I am going to move this 1 to the other side. So since it's subtracting 1, my inverse is going to be to add 1. And I get y equals 2x minus 5. So this right here is the equation of a line that passes through these 2 coordinate points. So we can definitely find that out just by having 2 coordinate points. I can figure out exactly what line it is, and I can graph the entire line if I needed to, okay? So you always start by finding your slope first, then plugging it into your point slope form. That's gonna simplify all the way down to your slope intercept form, okay? So we're going to skip over line of best fit. I'm gonna go ahead and see if I can find a decent video that won't confuse you guys all that much about line of best fit, that kind of goes over it without a graphing calculator. that means that we are going to go to slopes of parallel and perpendicular lines. So when we are dealing with parallel lines, they had the same slope, but different y-intercept values. Okay? They needed to have the same angle going up, just at different points on the y-axis. Okay? So for instance, those examples would be y equals 3x minus 4 and y equals 3x plus 2. They both have the same slope value of 3, but are at different points on the y-axis. That's the whole point, because at no point in time will these two lines ever intersect with each other. They're gonna be heading in the same direction, and they're always gonna have that same amount of space in between them. That same space between -4 and 2 is where those lines will be at, okay? Now, on the other hand, we talk about our perpendicular lines, okay? So when I tell you perpendicular, so perpendicular, okay? So they had opposite reciprocal slopes. So that means that one was positive, one was negative, so they're opposites. And reciprocals mean that one was the flipped version of the other. So let's take y equals 2x plus 1, y equals -1/2 x minus 4. So the y-intercepts don't really matter in this point, it's more the slopes, because that's where they're going to cross each other at a perpendicular angle, or it's going to be a right angle. Now remember, there's lines that cross all the time, but that doesn't mean that they are perpendicular. They have to be they are only perpendicular when they have opposite reciprocal slopes. So notice here we had a 2, so that's a positive 2, right? Its opposite would be a -2, but if we flipped it, it would be a -1/2. Remember that every single whole number always is over 1. So if we were to flip them, it would be 1 over whatever that whole number was, okay? So that is your parallel and perpendicular lines. Now the last part deals with transforming your linear functions. So when we talk about transforming linear functions, that deals with their slope and their y-intercept values. So when it was their slope, so the greater the slope, the steeper the line becomes. Okay, so let's say that I had two lines. One had a slope of 1/2, where another one had a slope of 4. That slope of 4 is going to be somewhere more like this, where the slope of 1/2 is going to be more like this. Okay? Notice that this 4 slope is a lot steeper, so try running up that hill. That's a lot steeper than this 1/2. Okay? Now, obviously the smaller it got, the less steep it got, okay? So the next part deals with your y-intercept. So your y-intercept is what moves your line up and down, okay? So y-intercept moves lines up or down, okay? So let's say that I had y equals 2x plus 1, y equals 2x minus 3, okay? So I transformed this line by moving it down 4 units. Because notice, from 1 to -3, that's a distance of 4 units down. So this line transferred down 4 units. So that's how you would go ahead and describe those. So that's essentially all that we're doing with the transforming linear functions, is we're describing what happens with each transformation. So again, slope deals with the steepness of your line, where y-intercept deals with the placement of it on the y-axis. So that's what moves it up and down. So think of it when we were doing the rotation of lines and the reflecting of it. It's the same kind of concept. Oh, that's what we forgot to do on this one. Nope, we'll deal with that in quadratics. All right, so that is pretty much all that we're doing for this lesson part. Okay, so this was 4.6 to 4.10. Now you have a MyHRW for 4.6, so that is for your slope-intercept form. So make sure that you're doing that, and you're also doing all the optional practices that I've given you. So those optional practices you can definitely take your time with doing, and you can prioritize the graded work, but I would love for you guys to do those practices. It helps your mind stay on top of it. So when we do have a test that we will have, or tests, quizzes, anything that we have, at least you've seen these problems and you've worked them out. And I'm more than welcome to work some of these out with you guys on the office hours, like I've told you a million times already. So definitely, if you need to, hop onto those office hours, okay? So again, any questions there, you can email me, put it on the Google Stream, whatever you need to do, but I look forward to seeing you guys. Bye.